Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Hello guys, welcome to Vaishnav 360. Today we are going to do functions from Maths 1A book, exercise 1A, Roman number 1, fourth problem. So, in the question, it is if f maps R is to R is defined by f of x is equals to log mod 1 plus x by 1 minus x, then show that f of 2x by 1 plus x square is equals to 2f of x. So in this question, we have to find out what is the RHS if in case of f of x it is f of 2x by 1 plus x square. So we will start the problem now. Now the first step is LHS. Now the given f of x. Now we should write the given f of x. F of x is equals to log mod 1 plus x by 1 minus x, right? Here in place of x we should enter f of 2x by 1 plus x square. So f of 2x by 1 plus x square is equals to log, here in place of x we should enter this, so log mod 1 plus 2x by 1 plus x square by 1 minus 2x by 1 plus x square. Okay, then in the next step we should take LCM in the mod. Log 1 plus x square plus 2x by 1 plus x square by 1 minus 1 plus x square minus 2x by 1 plus x square. Okay, it should be in the mod. Now denominators get cancelled and remaining it will be log 1 plus x square plus 2x by 1 plus x square minus 2x. Okay, now in the next step it is we can take 1 plus x square plus 2x as x square plus x plus 1 whole square, right? Or 1 plus x whole square, anything it may be. Okay, it is in the form of a plus b whole square, and here a minus b whole square. So let's take it log in the mod uh, x plus 1 whole square by x minus 1 whole square. Okay, in the next step we will take it totally in whole. So log mod x plus 1 by x minus 1 whole square. Okay, now there is a formula in which in logs this 2 as a power will change into the multiplication. So here the answer should be 2 log 2 log x plus 1 by x minus 1 in the mod. Okay, then here we can conclude 1 plus x or x plus 1 is same, 1 minus x or x minus 1 is same, right? So here we will see in the question what it is given here. Here 2x by 1 plus x square of f is equals to 2f of x. What is f of x? f of x is nothing but log 1 plus x by 1 minus x. So here we got x plus 1 by x minus 1. We can take it as 2 log x plus 1 by no. Here we should take 2 log in the mod 1 plus x by 1 minus x. Okay, here we can take it as this. What is log 1 plus x by 1 minus x? We can see here log 1 plus x by 1 minus x is f of x. So we have proved here that 2 into f of x is RHS. Okay, here this part is f of x, right? Here we have multiplied by 2 using the formula, that is log x to the power of n is equals to n of log x. Okay, this is the formula to change the power for the log to multiplication form. Okay, next we are going to do the fifth problem. Going to solve the fifth question, that is if a is equals to -2 -1 0 1 2 and f maps a to b is a surjection defined by f of x is equals to x square plus x plus 1, then find b. Firstly, I want to remind you what is surjection. Surjection is nothing but if the f maps a to b have the range and a codomain of same number of elements, then it is called as a surjection. Okay, I will again tell. A surjection is nothing but if a range and codomain of f maps a to b have the same number of elements in it, then it is known as a surjection. Now we will start the problem, fifth problem. Okay, we have f of x is equals to x square plus x plus 1. Now here we should find b. To find b, we should find f of -2 -1 0 1 2. All the elements in the a should be replaced by x. Okay, first we'll replace -2. F of -2 is equals to -2 whole square plus -2 plus 1. Okay, -2 into -2 4 plus -2 plus 1. Now 4 -2 plus 1. Now here 4 plus 1 is 5. -2 is -2. Then -2 is 5 minus 2 is 3. Okay, 3 is the solution of f of -2. Now we will find f of -1 is equals to -1 whole square plus -1 plus 1. 1 plus -1 plus 1. 1 plus 1 is 2 minus 1, that is 1. So the solution for f of -1 is 1. Now we'll search f of 0. For f of 0, it is 0 square plus 0 plus 1. Here we get 0 into 0 is 0, right? Plus 0 plus 1. Anything added with the with 0, the result is itself. So 0 plus 0 plus 1 is 1. Now the solution for f of 0 is 1. Now we will take f of 1. 1 square plus 1 plus 1. 1 square is 1 plus 1 plus 1. That is 3. 3 is the answer for f of 1. Now f of 2 is the last one in last element in set A. So f of 2 is 2 square plus 2 plus 1. Now the answer should be 4 plus 2 plus 1, that is 4 plus 2 6, 6 plus 1 7. Okay, this is the answer for f of 2. Okay, now these are these answers here. From here I will show you. From here these answers 3 1 again 1 and 3 and 7 are the set B, that is codomains. A is domains and B is codomains. I will represent it in diagrammatical form so that you can diagrammatical form so that you can understand simply or easily. So in A we have what elements? -2, -1, 0 and 2, right? In A we have -2, -1, 0, 1 and 2. These are the elements in A. And in B we have got the answers 3, 3, 1, again 1, again 3, again 7 and a 7, not again, because 7 is not repeated, no, that's why. First we have got 3, right? 3 is first, so write 3. We should not repeat the numbers again because a codomain can have two images. That is, I will show you now. This is 3, right? This here, this here. We should not repeat this again. So 3 here, 1 and 1 again. We should not repeat the 1 again. So here 1. Only once, and 7 is only once, right? So 7. I will show you how to represent it a surjection. Okay. See, 3 is twice, but I have written once. 1 is twice, I have written once, and 7 is single, so it is written as usual. Now I will represent it. For 2, -2, it is 7. Sorry, for -2 it is 3. -2 it is 3. For -1 it is 1. Now for 0 it is again 1. So like this. For 1 it is 3. From here till here. And for 2 it is 7. So it is of course here. So we should put arrow marks like this. For this diagrammatical form, arrow marks and the lines which represent the images are important. So the most important thing in diagrammatical form is we should not change the form of set. You can think that for 1 you can write 1 here and -1 here, and you can take it as 1 like this, and minus 1, minus 2 and 1 like this, but it is wrong. We should represent the same as there is given in this question. So you can see here the diagrammatical form of the fifth question. It is a surjection as, see, 1, 2 have 3 the same, so we can write it as 2. Two elements are, one element have two images, so we can write these two as single. This is one range, this is first range, okay. These two are the second range, this one is the third range. So every codomain has something or other image, so the range is equal to the codomain, okay. Range how much? 1, 2, 3. Codomains are how much? 1, 2, 3. One more thing. These are domains and this is codomains. Range is something which something in which a element has an image. If the element has an image, then we can take this number as range. So we have taken this number as range. If element does not have an image, then if there is something here 0 or 6, it might be 6. There is nothing here to give an image for this element, so this have been taken out, and the range is 1, 2, 3. 3, 1, 2 is the range, and 6 is taken out. But in codomain we can write 3176 as codomain. So I will remove this because it is not in this question. So here range is equal to codomain. So it is an surjection. Okay. So the actual answer without diagrammatical form we should write here as, see, A is equals to, okay, A is equals to minus 2 minus 1 0 1 2, okay. But the actual answer B is equals to 3 1 7. This is the actual answer which we can write in exams without showing the diagrammatical form. If they specify to show diagrammatical form in exam, we should write this answer. If they does not tell anything in the question, if the question does not tell does not relate anything about diagrammatical form, then we should write this answer. I think you do understand this. Now we are going to do the next one, sixth. Now we are going to do the sixth problem. The sixth problem is, if A is equals to 1, 2, 3, 4 and f maps A to R is a function defined by f of x is equals to x square minus x plus 1 by x plus 1. Then find the range. To find the range, we have here the domain 1, 2, 3, 4 in a set. We should find codomain. If there are 4 domains, there should be 4 codomains. If there is 4 codomains, it is the range. So we should find codomain first to find out the range. To find the codomain, do uh, we should do x, which is here, should be replaced by every element in domain. Now we'll do the first step, that is f of x is equals to x square minus x plus 1 by x plus 1, okay. then we should replace x by 1. Now here it is x is replaced by 1. Now here every time x is here, then we should write 1. 1 square minus 1 plus 1 by 1 plus 1 is equals to 1 square is 1 minus 1 plus 1 plus 1 minus 1 cancels. Here 1 plus 1 2 is equals to 1 by 2, that is 0.5. Okay, for the first one f of 1 is equals to 0.5. Now f of 2, because in the set A there is 2, so we will take 2. Okay, 2 square minus 2 plus 1 is equals, sorry, by 2 plus 1 is equals to 2 squares 4. 4 minus 2 plus 1 by 3. 4 minus 2 is equals to 2 plus 1, that is 3 by 3, then it is 1. Now f of 3 is equals to 3 square minus 3 plus 1 by 3 plus 1 is equals to 3 square is 9 minus 3 plus 1 by 3 plus 1, that is 9 minus 3 is 6, 6 plus 1 is 7, 3 plus 1 is 4. So 7 by 4 is nothing but 1.75 is the answer for f of 3. Now the last one, it is f of 4 is equals to 4 square minus 4 plus 1 by 4 plus 1 is equals to 4 squares, 16 minus 4 plus 1 by 5. Then 16 plus 1 17 minus 4 by 5. The answer is 13 by 5. 13 by 5 is nothing but 2.6. 2.6. Now we have got the codomain, that is B. No, that is R. In question they are mentioned R, so it is R. So R is equals to 0.5, 1, 1.75, then 2.6. This is actually codomain, but we can directly represent it as a range, because there are four domains and four codomains. So range is also the same number of elements. So what is range? The four elements in codomain. So we have directly represented R as the range and then directly noted the answer. Now we will do the next sum, that is seventh. So now we are going to do the seventh problem, that is, if f of x plus y is equal to f of xy, x comma y belongs to R, then prove that if f is a constant function, x and y should be a number through which we should prove that f is a constant function. So now we should take numbers from 0 to 2. Okay, we should take numbers from 0 to 2, that is x is equal to 0, y is equal to 0, then x is equal to 1 and y is equals to 0, and x is equals to 1 and y is equals to 1, and x is equals to 1 and y is equals to 2. We should try all these and we should find out if all the elements that are of x and y are equal to the same, which is what we can say is x is equals to 0 and y is equals to 0 if we take, and then in again x is equals to 1 and y is equals to 0 if the property is here and there is equal to and this is equals to this, then it is a constant function. Okay, we will try this and you may understand while solving the problem, so be attentive. Okay, we will start the problem. Now first we should take the given f x plus y is equals to f of x plus y is equals to f of xy. Okay, from now let's take x is equals to 0 comma y is equals to 0. Okay, now we will take here x plus y and xy. No, here we will take this format and continue. X is 0, y is 0, 0 plus 0 is 0 is equals to f of x into y, 0 into y is 0 into 0 is equal to 0, so f of 0 is equals to f of 0. This is same, so this can be a constant function. Okay, now we'll take the next one. Let x is equals to 1 comma y is equals to 0, f of 0 sorry f of 1 plus 0 and again is equals to f of 1 into 0. Okay, yeah, 1 into 0. F of 1 is equals to 0, f of 0. Okay, this is first equation we will take, this is second equation. Okay, now we will do the third one. Let x is equals to 1 comma y is equals to 1. Okay, f of 1 plus 1 is equals to f of 1 into 1. Now it is f of 2 is equals to f of 1. This is third equation. Now we will take fourth equation. Let x is equals to 1 and y is equals to 2. Okay, now we have increased the number of y here, that is 2 now. Now f of 1 plus 2 is equals to f of 1 into 2. F of 3 is equals to f of 2. Okay, this is fourth equation. From all the equation we can conclude that, therefore from equations 1, 2, 3, 4 we can conclude that f of 0 is equals to f of 1 is equals to f of 2 is equals to f of 3. How it may be concluded? See here, f of 0 is equals to f of 0. Okay, it may be equal, it should be equal because 0 and 0 have same, no, so it is 0 only. Now here f of 1 is equals to f of 0, here f of 0, here f of 0, so f of 0 is equals to f of 1. Here in answer we have took f of 0 is equals to f of 1 here. Okay, then again here f of 2 is equals to f of 1, here f of 1, here f of 1, here f of 2, so 1 f of 1 is equals to f of 2. In answer we have written f of 2 is equal f of 1 is equals to f of 2. Okay, now here last one, f of 3 is equals to f of 2. Here 2 f of 2, here f of 2, same, right? Now here f of 3 is equals to f of 2. The answer is what? F of 2 is equals to f of 3. So totally we can write it as f of 0 is equals to f of 1 is equals to f of 2 is equals to f of 3. Now we can conclude it totally that now given function given function is a constant function. So now we have completed the seventh problem.